Recording started.
Let's talk about basic right triangle or right angle trigonometry. So here you go. Here's all our definitions. For example, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and so on. These are all on your formula sheets. Let's go immediately to an example and see how we're going to put these things into use. All right, let's say I have a nice triangle here. Say it's a right triangle. Call this angle theta. And let's say I'm told that the two legs are 15 and 8. And the hypotenuse then turns out to be a 17. So let's start looking at these things. So the sine of theta is always going to be the opposite over the hypotenuse. That's 8 over 17. Cosine of theta is going to be the adjacent side, 15, over the hypotenuse is 17. Tangent of theta is going to be the opposite over the adjacent, so 8 over 15. The other three, cosecant theta is going to be the hypotenuse over the opposite side. Secant theta is going to be the hypotenuse over the adjacent side. And finally, cotangent theta will be the adjacent side over the opposite side. So I can use all those formulas to tell you the 6 trig functions for any of those angles. In the homework, you'll see examples that talk about an angle of elevation and an angle of depression. Real simple. Let's say this is the horizon line. If you are looking up, that's going to be an angle of elevation. If you are somewhere and looking down, so let's say this line represents the path of a plane, and you're looking down, that would be the angle of depression. That's all they mean by elevation and depression. So let's talk about an example using those. Okay, here we go. From a window, 30 feet above the street. The angle of elevation to the top of the building across the street is 50 degrees. The angle of depression to the base of the same building is 20 degrees. Find the height of the building. Okay, well, let me draw that out for you. I think I'll need another slide. So let me get a new slide and I'll draw that out for you. Here's our first building. And then directly across the street will be another building, maybe a little taller. But there's our other building. And it's very clear that I failed out of art school, but these are still going to be buildings. So we're at a window, say, 30 feet above the street. So we'll say this is 30 feet above the street. From that window, the angle of depression down to the base of that first of the building across the street, they said it was a 20-degree angle. So what I'm going to do is I'm going to fill in kind of a dotted line here. That's my line straight across to the other building. So this angle right here should be 20 degrees. And the angle up here to the top of the other building, this angle should be 50 degrees. We're supposed to find that height. Well, we can't right at the moment. So what I'm going to do is fill in a couple of other things I know. We know that if we look directly across this height here, that should be 30 feet. I'm going to break this problem up into 2 steps. The first thing I'm going to do is I'm going to find the distance, this horizontal distance between the 2 buildings. Okay. Once I do that, then I'm going to come back and I'm going to find this side of the upper triangle, and I'm going to add that to the 30 feet. So let's start out with the find that horizontal distance between the two buildings. I'm going to start with this lower triangle, and I'm going to say I've got the side opposite, and I want to know this side adjacent. That sounds like a tangent. So if I take the tangent of 20 degrees, that should be equal to the side opposite. That's 30 feet over the side adjacent. Let's call this side x. So I'll call it x. I'm going to solve for x. So what I'm going to do is just think of this as proportion and cross multiply. So x should be, let's see, 1 times 30 should be 30 divided by the tangent of 20 degrees. And I'll put that all into my calculator. And I'll get 82.4. This guy is 82.4. Next, I don't have enough room on this slide, but we'll get it on the next one. The next thing I would like to do is find this height up here. We'll call it h. So what I'm going to do is I'm going to say the tangent of 50 degrees should be that side h divided by 82.4. Right? Because it's supposed to be the opposite over the adjacent. H is now the opposite side over the adjacent, which we just solved for, is 82.4. Again, I'm going to think of this as a proportion and just solve for h. So h will be, well, it's going to be 82.4 times the tangent of 50 degrees. When I plug that into my calculator, I get a value for h of 98.2 feet. So I say h is 98.2 feet. But you're not done, because remember on our sketch, and let me just remind you of our sketch. We had two little triangles. We had this triangle going down. We had this triangle going up. What we just found was h, this side right here. We knew the bottom to be 30, so I've got to add those two together. So the total height, the height of the building, is going to be 30 feet plus the 98.2 feet. So I'm going to get a total, grand total here of 128.2 feet. And that deserves a better pen color. So that's our answer to our problem.